Welcome back to Java Internals Crashcasts. I'm your host Sheila, and today we're diving into the exciting world of threads in Java. We're starting a new chapter called Thread Basics in our Fundamentals of Concurrency season. Victor, are you ready to unravel the mysteries of thread creation?
Absolutely, Sheila. I'm excited to explore this foundational concept with our listeners. It's going to be a thread-rific episode.
Oh, Victor, your puns never disappoint. Before we jump in, listeners, make sure you're familiar with basic Java concepts like classes and interfaces. Now, let's kick things off with a quiz question. In Java, what's the difference between calling the start method and the run method on a thread object?
Ooh, that's a great question, Sheila. It touches on a crucial aspect of thread behavior that often confuses developers. I'm curious to see how many of our listeners can spot the subtle but important distinction. What do you think, Sheila? Why did you choose this particular question?
Well, Victor, I chose it because it highlights a common pitfall in thread creation and execution. It's one of those things that can trip up even experienced developers if they're not paying attention. But let's not give away too much. We'll reveal the answer at the end of the episode. For now, let's start with the basics. Victor, could you explain what a thread is in Java?
Certainly. In Java, a thread is the smallest unit of execution within a program. You can think of threads as workers in a factory. Just as multiple workers can perform different tasks simultaneously in a factory, multiple threads can execute different parts of your program concurrently. The thread class in Java represents these workers, and it's the foundation for creating and managing threads in our applications.
That's a great analogy, Victor. So how do we actually create these worker threads in our Java programs?
There are several ways to create threads in Java, Sheila. The two primary approaches are, first, extending the thread class, and second, implementing the Runnable interface. Let's start with extending the thread class. This is the most straightforward method, but it has some limitations. Imagine we're creating a specialized type of thread by defining what it should do when it runs.
I see. So we're basically creating a specialized type of thread. But you mentioned limitations. What are those?
Good question, Sheila. The main limitation is that Java doesn't support multiple inheritance. If your class extends thread, it can't extend any other class. This can be restrictive in terms of design flexibility. That's where the second approach comes in, implementing the Runnable interface.
I remember the Runnable interface from our previous discussions. How does that work for creating threads?
Implementing Runnable is generally considered a better practice. It's like creating a task list that can be given to any thread. This approach separates the task, what to run, from the thread, how to run it. It's more flexible and allows your class to extend other classes if needed.
That makes sense. I notice we're using the start method in both cases. Is that how we actually get the thread running?
Exactly, Sheila. The start method is crucial. It tells the Java Virtual Machine, or JVM, to allocate resources for the thread and call its run method. This is where many developers make a mistake. They directly call the run method instead of start.
Oh, interesting. What happens if you call run directly instead of start?
If you call run directly, the code will execute in the same thread that called it, not in a new thread. It's like asking a worker to do a job right now, instead of hiring a new worker to do it separately. This defeats the purpose of using threads for concurrent execution.
I see why that was our quiz question now. It's a subtle but important distinction. Victor, you mentioned earlier that there are several ways to create threads. We've covered extending thread and implementing Runnable. Are there more modern approaches?
Indeed there are, Sheila. With Java 8 and later versions, we can use lambda expressions to create threads more concisely. Lambda expressions are like shorthand ways of writing small functions. They're particularly useful for short, simple thread tasks. Instead of defining a whole new class, you can just write a quick instruction for what the thread should do.
That sounds much more compact. It seems like Java has evolved to make thread creation easier over time. Are there any real-world scenarios where understanding thread creation is particularly important?
Absolutely, Sheila. One common scenario is in web servers. When a server receives multiple requests simultaneously, it often creates a new thread to handle each request. This allows the server to process multiple requests concurrently, improving performance and responsiveness.
That's a great example, Victor. As we wrap up, could you summarize the key points about creating and starting threads?
Certainly. Here are the main takeaways. 1. Threads can be created by extending the thread class or implementing the Runnable interface. 2. Implementing Runnable is generally preferred for its flexibility. 3. Always use the start method to begin thread execution, not run. 4. Modern Java allows for concise thread creation using lambda expressions. 5. Understanding thread creation is crucial for developing efficient, concurrent applications.
Excellent summary, Victor. Now let's reveal the answer to our quiz question. What's the difference between calling start and run on a thread object?
The key difference is that start creates a new thread and calls run in that new thread, while calling run directly just executes the method in the current thread without creating a new one. Always use start when you want true multi-threaded behavior.
Thank you, Victor, for this illuminating discussion on creating and starting threads. Listeners, in our next episode, we'll dive deeper into the thread lifecycle. Don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you enjoyed this episode. Until next time, keep those threads running smoothly.